Hello students, welcome to Educate. In the last video of chapter 4, that is D and F block elements, I have guided you how to draw the predict table, and some additional information I have also provided about D and F block elements. Now we just go through the NCERT books and refer to that if there be any information left, then I shall provide you. Let's see. You already know D and F block elements. What is D block elements? The elements in which the last electron enters in d orbital, that is called D block elements, and the elements in which the last electron enters in f orbital, that is called F block elements. Keep in the mind, in case of D block elements, the last electron enters in penultimate cell. Penultimate cell means one cell inner to the valence cell. You know, valence cell is the outermost cell, and second outermost cell is called penultimate cell, and one more inner to that will be called inner penultimate cell. So in D block elements, the last electron enters in penultimate cell. In case of F block elements, the last electron enters in inner penultimate cell. Okay. Now position in the periodic table, what is that? You have already studied. The D block elements lie between that of the S block elements and the P block elements. Electronic configuration, a rough idea I have given you how to write the electronic configuration. I think you know, and someone also don't know, might be someone will not know how to write the electronic configuration. Main challenge here is how to write the increasing energy level. You have studied in class 11 like this one. And how to write their increasing energy level? Goes from tail to head, and of the next arrow again go to the tail and come to head. Again on the tail you go, and then after come to head. So energy level will be three S, then after here and so on, like this one. You cannot write. From tail to head come, again go to the tail, then come head, again go to the tail, come at head, 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 again go to the tail and come at head. In this manner. But this one is time taking. In the examination, you will not get sufficient amount of time so that you draw. So I tell you a simple technique, and if you forget the energy level, and also I shall tell you how to write the increasing energy level. That will be helpful for you IIT main examination as well as in NEET examination, because how much time there will be for the NEET examination and for the IIT main examination, you already know how much time you will get and what be the importance of time, that you will realize more accurately during the examination of IIT main and the NEET examination. Okay, now let's see here. So I tell you how to draw the energy level, and you may match from here also. How to write? Simply draw a triangle, and to this one lines. Here 1s, 2s, 2p. That means this side s and this side p. That done. Then after every two lines, new types of orbitals will enter. Like these two lines here. After these two lines, there will be 3D. And after again these two lines, 4F will start. Keep in the mind, 3D starts after 4S and 4F starts after 6S. So increasing energy level will be after 6S there will be 4F. And that will continue. Simply from 1S, then 2S, 2P, 3S, 3P, 4S, 3D, 4P, 5S, 4D, 5P, 6S, 4F, 5D, 6P, 7S, 4F, 67P. Like that. Now, in the IIT main examination, you will not get that time. Here, for this one, if it's not time to, so much time it will take, so you can apply in the 12th board examination. But for the IIT main examination, if you will write down and then after will write, so that will be time taking. So better here I am telling you. So 3D starts after 4S. Then after obviously after 4S there will be 4P only. And after P orbital when complete, then after again that will start from S. So there was 4S, then after 3D, then 4P. After that 5S will start, and 5 increment will be from 5S. So 5S, then after again 4D and 5P. Then after is 6S. But after 6S, penultimate cell will be there. That means 4F will be there. 6th valence cell, penultimate cell will be 4th cell. There 4S was the valence cell and 3D was penultimate cell. So same here 6s valence cell, then after will be inner penalty met cell. So 4f, then 5d, then 6p. After that 7s, then after 5p or 5f, then 6d and 7p. Okay, so 1-2 times you practice also, then that will be fixed in your memory. So after 4s there will be penalty met cell, and after 6s, after 4s, there after 6s there will be penalty met cell, that is 4f will start. Okay, so that is here. So when you write the electronic configuration, I have already told you there be exception of the electronic configuration at chromium, copper, palladium. Okay, in that one, in 3D series, chromium and copper, and at palladium also. What is here? Chromium, electronic configuration, atomic number of chromium is 24. So what is? That would be the electronic configuration, but that will be not. As in case of copper, we have studied that the half-filled and the fully filled d orbital provide extra stability to the atoms. That's why one electron from 4s enters into 3d. So electronic configuration of chromium will be here 4s1 3d5. So you write that here, and firstly we write this one, because 4s is the valence cell and this is increasing energy level, and when we will have to write the electronic configuration in case of cell wise, then the 4s that will come after 3d. So 4s2. So one electron from 4s enters into 3d. So electronic configuration will become so here 3d5 4s2. Here will be 3d5 and 4s2. So order 4s1. 3d5 4s1. That will be for chromium. Same copper. Same copper. Copper atomic number is 29. So electronic configuration would be that would be the electronic configuration, but that will be not the electronic configuration of copper, because the half filled, if one electron from 4s will enter in the 3d, then the 3d orbital will become fully filled, which will provide extra stability to the copper atom. That's why the electronic configuration will become, outermost electronic configuration will become 3d10 4s1. So write that electronic configuration will be this one copper. Exception here palladium. Palladium, what's the atomic number of palladium? Watch out here on this one, nickel just goes up to that. Atomic number is 28 on bit of the group. So how much will get added? You can also predict, go to the predictable. So if you will add 18, so 28 plus 18 goes to the predictable. Between nickel and palladium, there be 18 elements. This side here and that side here. Adding all of them. So 18 elements be there. So add here 46. So palladium electronic configuration, what to write? Oh, palladium here, this one not 10, there will be 8. That will be the electronic configuration, because what will happen here, if there be 4d8 and 5s2, so from here the 2 electrons goes into the 4d, so that's why electronic configuration will be here 5s0 and 4d10, and that is exception only for palladium. The 2 electron from the palladium fall from the 4s orbital. In case of palladium, the 2 electron from 5s will enter into 4d, and hence the electronic configuration will become this one. That was the exception in electronic configuration. Remaining stories here, I have already given you the concepts of related to this one. Now let's see here. Watch out this question. I have already told you how the scandium is a transition metals, because scandium was containing incomplete d orbital. The electronic configuration of scandium was, the outermost electronic configuration of scandium was 3d1 4s2. So d block d orbitals contain incomplete d orbital. That's why scandium is a transition metals. But among zinc, in zinc don't contain incomplete d orbital, because outermost electronic configuration here is 3d10 4s2, and for Zn2 plus, zinc shows only one oxidation state, that is +2. So electronic configuration of Zn2 plus will be that lastly 3d10. So in the both the cases, the scandium contain incomplete d orbital in atomic state, but zinc don't contain incomplete d orbital either in atomic state or in its oxidized form. Hence, zinc is not a transition metals. About that, I have also discussed previously. So if you have any difficulty, you watch out the previous video. Then after is the general properties of transition elements. As the name indicates, transition elements, so their metallic properties will be in between of S block and that of the P block. So first one is about the melting point. First one is here, they are malleable. They are malleable, high tensile strength, ductility and malleability. What's the reason here? That means the D block elements are possess high tensile strength, ductility, malleability and high thermal and electrical conductivity. What's the reason about that? Before going on this topic, we should understand what is metallic bonding. That is, between the metals, which types of bond takes place and how that bonding be there among the atoms of transition metals or any other metals. Okay, just like that here, before that just goes on how to make the chapati. Before making the chapati, the cook, any cook, that firstly cook, maybe your mom, maybe your domestic worker, or maybe your maid, anyone, maybe. So what's the she or he firstly do? So firstly he or she mix water with the flour of the grains which you consume, like wheat flour or corn flour, whatever be that. So he mixes the water with the flour. So suppose this is the grain of flours. Between these flours there be water. Suppose this. Now what happened? Watch out about this water. This water particle, will be bonded to this grains of wheat flour, as well as this grains of flour. This one will be bonded to this one, as well as this one. This one will be also bonded with this one. This will also bonded with this one. So no any particular flour grain will be bonded with a particular water molecule. That means one grain of the flour will be bonded with a number of water molecules, and in the same way one water molecules will be bonded with a number of flour grains. So what happened here? So when hammering will done, or when a mechanical force will apply like this, then these particles will replace the other particles, will acquire the new space, but bonding will not dissociate. Suppose drops of this flour here. So if a pressure applied over this one, rolling on the dub of the flour, that creates here in the uniformity, that creates the pressure over this one, and these particles spread like this and chapati forms. But bonding between the grains of the flour and the water don't break. So that's why that is malleable. In the same way, there be the metallic bonding. Just watch out for the firstly iron we take. So just watch out for the iron. What happened? Firstly, all the irons loses their electron, and the remaining portion left, that will be called kernel. Means after losing the valence electron, the remaining portion left, that will be called kernel. And in this kernel, that will be iron, there will be Fe3 plus will get distributed. In the oxidized form, or if that will be inside the solution or in the vapor phase, then we will call it the ions. And during the course of metallic bond formation, that is called kernel. This Fe3 kernels, Fe3 plus will get embedded. So what happened? This kernel will be not only bonded to this electron, that will be bonded to this electron, this electron, this electron, this electron, this electron, and this electron is also bonded to this kernel, this kernel, this kernel, this kernel, like this. So here any particular kernel will be not bonded with a particular electron. One kernel will be bonded with a number of electrons, and one electron will be bonded with a number of kernels. So when mechanical force will apply, then the kernels will acquire the new position, or one kernel will displace the other kernel. But the bonding between the kernels and the electron will not dissociate. The bonding between kernels and the electron will not dissociate. So, on hammering, there will be no breaking of the bonds, but that will be drawn into shifts, or when mechanical force will apply like this, when the mechanical force will apply like this, so one kernel will displace the other kernel and few kernels will acquire the new position. So that's why here that will be malleable, ductile, and that have high tensile strength. Among S block alkali metals, alkaline earth metals, compared to S block elements, the D block elements possesses high tensile strength. Why? Because during the metallic bond formation, there be involvement of moved electron. In case of D block elements, since there is a number of electrons in d orbital, there be a number of unpaired electrons in d orbitals, which could involve in metallic bond formation. That's why in the metallic bond formation, there be involvement of a number of electrons to which the kernel will be bonded. That's why the strength of this metallic bond will be high, and when the strength of metallic bond will be high, their melting point will be high, tensile strength will be high, as well as the enthalpy of atomization, that will be also high. Okay, so melting point or boiling point, melting point, whenever you will have to consider about the melting point and the boiling point, you will have to consider about the force of attraction operating between the constituent particles. In case of D block elements, since the participation of electron is more in metallic bond formation due to presence of incomplete d orbital in D block elements. Hence, the transition metals will possess greater melting point than that of S block elements, as well as high tensile strength than that of transition metals. Let's see, that was about why the D block elements possess greater tensile strength and the melting point compared to that of S block elements. Now we discuss here the trends of melting point in D block elements. Watch out this one carefully. So what happened from titanium it has taken? So melting point increases till chromium, and then after the melting point of manganese has decreases sharply. That means there is a dip at the manganese. Okay, then after the melting point of iron is greater, and then after of the copper, of the cobalt, palladium, platinum, copper, that decreases like this, and zinc will be also less. Same, there is the trend. That's the trend. First, let's see, and then after I shall tell you what's the reason. You also think why that is happening. Now let's see here what the actual trend is here. Firstly, watch out on that. So here also the melting point is increasing and dip is comes at tectonium, and then after again the melting point increases and then after decreases, and the boiling point of silver less. Same here, melting point increases, here tungsten and this one. After then decreases. Okay. From this graph, one you can predict that among D block elements, the tungsten possesses, W is tungsten. This tungsten possesses highest melting point. The tungsten possesses highest melting point. Okay. Then after here, and that was the question of maybe asked in the CUAT examination, and I think I'm not sure that this question was asked in CUET examination in the previous year or not. I am confused about that. But if this question has not asked, then that may ask in the future. May ask, have asked or not. But in future, this question may ask that among D block elements, which element possesses highest melting point? Okay, among D block elements, which element possesses highest melting point? But that was the question here. What was, you just goes on later on, you will go on the later on. That is the which element shows highest number of oxidation state? Among D block elements, which element possesses highest number of oxidation state? That question was asked. So answer was here. Among 3D series, question was among 3D series, which element shows maximum number of oxidation states? So manganese. And in main examination, less chances, but that is chances there. Among D block elements, which element possesses highest number of oxidation state? So in whole of the D block elements, the molybdenum shows highest number of oxidation state. And in 3D series, the manganese shows highest number of oxidation state. Now that was the critic trend that we have discussed. Now let's see about what's the reason why there be here in the manganese there be dip. So that is based on the electronic configuration for manganese as well as for tectonium. So goes on the electronic configuration of manganese. Manganese atomic number 25. So electronic configuration will be here 3D orbital is, and that is in the increasing order, and when you will have to write in the cell wise. So 4s2 will come later on. Because valence cell is the S cell, 4s cell is the valence cell. So 2 electron will release from 4s. So in case of manganese, since after releasing 2 electron from 4s, the valence orbital will be half filled, which will provide extra stability to the manganese. So here the participation of electron will be, participation of 3D electron in the metallic bond formation will be difficult. So less number of electron will involve in the metallic bond formation of manganese. As a result, the strength of metallic bond will be less and that melting point will be less. In the examination, question will ask in the IIT main or in the NEET examination as well as in CUET examination, there will be option, and that's you should know only, you should have the idea what is the reason. But in the 12th board examination, you will have to write also. That is, question will be in the form of give reason, and one will be why the manganese possesses least melting point among the elements of 3D series. So you will have to write, firstly you will have to write the electronic configuration, and then after you will have to write, since after losing 2 electrons, the valence orbital will be half filled. So the tendency, the involvement of less number of electron will be in the metallic bond formation, and hence less number of electron will participate in metallic bond formation. As a result, the strength of metallic bond will be less, and the strength of metallic bond will be less, so that will possess least melting point among the D block elements. Okay, write the electronic configuration, and then after write, since after losing the 2 electron, the valence orbital will be half filled, and hence less number of electron will involve in the metallic bond formation in case of manganese, and hence manganese possesses least melting point among the 3D series. Now then after again from starts decreasing. Why? Because pairing of electron will now, then after pairing of electron starts from the manganese. After that manganese, when you go on the iron, that will be 3d6. So 5 orbital there be. So pairing will start here. One electron occupied by all of them. Then after only one option, that means pairing of electron will take place. So when the pairing of electron will take place, again the tendency to form metallic bond formation will decrease. Here from titanium, scandium to here, vanadium to chromium, sorry, not vanadium only, to till chromium. The number of unpaired electron was increasing. At the manganese, the number of unpaired electron has become maximum. The number of unpaired electron in case of manganese has become maximum. But instead of increasing the melting point, there will be decrease in melting point. What's the reason? I have discussed. Then after here is, after that here from the iron, pairing of electron begins, and hence the number of unpaired electron starts decreasing. As a result, the melting point of these elements starts decreasing. Okay, same for here tectonium also, and these elements also. Okay, now proceed. Enthalpy of atomization. Because the melting point and the enthalpy of atomization both depends on the strength of metallic bonding. The enthalpy of atomization. What is enthalpy of atomization? How much energy will have to provide to separate the atoms. That will be called enthalpy of atomization. And the enthalpy of atomization, if the constituent particles will be bonded tightly, then greater amount of energy will have to provide to separate the atoms. Hence, greater amount of energy will have to provide to separate the atoms. So, in that case, the enthalpy of atomization will be more. More be the strength of metallic bonding, more be the enthalpy of atomization. Because if the strength of the metallic bonding will be more, then we will have to provide greater amount of energy to separate the atoms. And in case of melting point, what happens? In solids, the distance between the constituent particles are less, and in liquid, the distance between the constituent particles are more. So, in case of here, when we will have to consider about the melting point, then also we will have to consider about the strength of metallic bonding. And here same periodic trend, approximately same periodic trend has been observed in case of enthalpy of atomization as there was in case of melting point. Same factor there is for both of them. So that's why the graph will be approximately same as that of melting point. Then after, let's see about variations in atomic and ionic sizes of transition metals. Goes on the graph, and by this graph you can predict a number of phenomena, and by the basic concepts of chemistry you can answer about their reason also. Let's see here, first work case. The 3D elements, when we consider about the atomic size. So as we move across the period, what is happening? The atomic radii decreases. Like that of atomic radii of scandium is that much, atomic radii of titanium is that much, that of vanadium is that much, chromium that much, manganese that much. One thing, have you noticed that initially the difference in the atomic size is more, and as after that the difference in the atomic size decreases, and the atomic size of last elements again increases. Watch out here. So as you hear difference of this atomic size, more, then after less, again less, again less, less, approximately same, slightly more and more. That is here. So what is that? We can say that on moving across the period, the atomic radii decreases, but the extent of decrease in atomic radii, that also decreases, and the atomic radii of the last elements, that increases. This one concept is here. What's the reason here? That as we move across the period from the middle, after the middle, what happens? Pairing of electron will take place. So suppose here nucleus, pairing of electron will take place. So there will be electronic repulsion between the electron present in same orbital. There will be repulsion between the electron present in the same orbital. So here size of orbital tends to increase, but the atomic number is increasing, so size will obviously decrease, and here it tends to increase. So there will be decrement in the atomic radii, but that will be not so much as it was predicted, because the electrons present in the same orbital will repel each other. As a result, the size of atomic orbital will increase. So the extent of decrease in atomic radii, that will decrease, because here repulsion between the electron present in the same orbital, that will tends to increase the size of orbital. That was. Now one point also you can watch out by watching this graph. What happened here? the atomic radii, suppose here this element is that much, this element that much. Now this one and this one. So atomic radii, this one and this one, when you compare about these two, that will be. So the elements of 4D series, the atomic radii of the elements of 4D series, this one is significantly greater than that of the elements of 3D series. The atomic radii of the elements of 4D series is significantly greater than that of the elements of 3D series. But what happened here? The elements of this 5D series possesses approximately same atomic radii as that of 3D series or 4D series in their corresponding group. The elements of 4D series, possesses significant greater atomic radii than that of 3D series in their corresponding period. In their corresponding group. But the elements of 5D series possesses approximately same atomic radii as that of 4D series. What's the reason here? Because in the elements of 5D series, there are 14 electrons present in 4f orbital. There be 14 electrons present in 4f orbital, which has poor screening effect. That's why the atomic radii will not increase as was expected. What is a screening effect? Let's see. When we write the electronic configuration here by the cell wise, this is nucleus, this first cell, second cell, third cell. So nucleus attract the electron of first this electron. Nucleus also attract the electron present in second cell. But that means nucleus attract the electron, this electron, and this electron also repel this electron. This repulsion. So what will be the attractive force here? Their magnitude will decrease, because one attractive force will be towards the nucleus. The nucleus will attract the electron, but the inner electron repel this outer electron. But the inner electron will repel the outer electron, so attractive force will be not as much, and this repulsion, that is called a screening effect. Or that is also called shielding effect. What happened in case of D block elements? So D block elements here, their screening effect is very poor. That means they don't repel the outer electron of the outer cell as effective as the electron of S and P repel. And F orbital have approximately no screening effect. So F orbital here, F electron present in 4f orbital, that have approximately no screening effect. So when there will be no screening effect, so force of attraction will be very high. When force of electron will be very high, so outermost electron will tends to come closer to the nucleus. But the electron has been added in the outermost shell, so there will be increasement in the size of the atom. But due to this poor screening effect of 4f orbital, there will be decrement in the atomic, not more increment in the atomic radii. So question in the examination will ask why the elements of 5D series are of approximately same atomic radii than that of 4D series. If in the examination you will not have the time, so simply write due to lanthanoid contraction. Due to lanthanoid contraction. Okay, so and which is due to the presence of electron in 4f orbital. That only you will have to write. So from here, one question forms for the 12th board examination. And from the previous topic and from this topic. Here, the reasoning based on which will provide possesses greater boiling point, melting point, that about the enthalpy of atomization, and frequently asked question is why manganese possesses less melting point and same as tectonium. That question asked. So here these are the topics about which we have discussed. In the next video, we will discuss about ionization enthalpy. It's all for this class. Thank you, Team Educate.